right-angled triangles, and Pythagoras property. A Greek philosopher, Pythagoras, is said to have found a very important and useful property of right-angled triangles, known as Pythagoras property, named after him. The sides of a right-angled triangle have special names. The side opposite to the right angle is called the hypotenuse, and the other two sides are known as the legs of a right-angled triangle. For example, in triangle ABC, right-angled, at B, AC, is the hypotenuse, and AB and AC are the legs of the triangle ABC. Now let us perform an activity to understand the Pythagoras property. For this, make 8 identical copies of a right-angled triangle, say triangle PQR, as shown, with length of the hypotenuse as A units, and the legs as B units, and C units. Draw 2 identical squares on a sheet with sides of lengths B plus C. Now place 4 triangles in one square, and the remaining 4 triangles in the other square, as shown. On doing this, we find that the uncovered area of square A is equal to the uncovered area of square B, because the 2 squares are identical, and the triangles inserted are also identical. Which means that the area of inner square of square A is equal to the total area of 2 uncovered squares in square B. That is, A square is equal to B square plus C square. This is Pythagoras property, and it may be stated as follows. In a right-angled triangle, the square on the hypotenuse is equal to the sum of the squares on the legs. Let us see the practical verification of this theorem. Draw a right-angled triangle on a square sheet of paper, as shown. Construct squares on all the 3 sides of the triangle. Now compute the area of these squares. On computing, we find that, for any right-angled triangle, the area of the square on the hypotenuse is equal to the sum of the areas of the squares on the legs. We have just verified that, if we have a right-angled triangle, then the Pythagoras property holds. Now we will show that, if there is a triangle, such that sum of the squares on 2 of its sides is equal to the square of the 3rd side, it must be a right-angled triangle. For this, we should have cutouts of squares with sides 4 centimeters, 5 centimeters, and 6 centimeters long. Arrange them to get a triangular shape by placing the corners of the squares, as shown. Trace the triangle formed. Measure each angle of the triangle. We find that each angle is an acute angle, that is, the triangle is an acute angled triangle. Also, note that 4 square plus 5 square is not equal to 6 square. 5 square plus 6 square is not equal to 4 square. And 6 square plus 4 square is not equal to 5 square. let us repeat the above activity with squares whose sides have lengths 4 centimeters, 5 centimeters, and 7 centimeters. In this case, we get an obtuse angled triangle, in which 4 square plus 5 square is not equal to 7 square. 5 square plus 7 square is not equal to 4 square. And 4 square plus 7 square is not equal to 5 square. Now take squares whose sides have lengths 3 centimeters, 4 centimeters, and 5 centimeters. Here, we get a right-angled triangle, in which 3 square plus 4 square is equal to 5 square, that is, Pythagoras property holds. This shows that, if the Pythagoras property holds, the triangle must be right angle. In this triangle, note that hypotenuse is the longest side, as its square is equal to the sum of squares of other two sides. Thus, hypotenuse is the longest side of a right triangle.